So, by a show of hands, how many of you think you're pretty much done? Okay, that's two. It's two better than before. All right. I guess I can talk about some things a little bit today, but I guess I was primarily hoping to answer your questions. And if things peter out too much, and I don't have much on Thursday, I may just move on to different topics on Thursday. As you recall, this has a due date over this coming weekend, next Sunday. So, do you have any questions for me then, I guess is what I'm trying to say. How many people have started? All right, all right. Any? No questions? Yeah.
For step 3, could you demonstrate how to compile a test program to test the symbols class?
Test 3. Yes. Let's look at this. For you mean this item right here?
Yeah.
All right. Let's see, how shall I do this? Okay, they're there. So let me look at the header file for this symbol class. Whoops. Okay, so it's a little, I know what I can do. How about if we do that? There we go, that's a little better. Alright, so here are my public functions for symbol. So let me call this test symbol.cpp. I'll go ahead and bring this little template in. I'll pound include symbol.h. Symbol. Let's see, my int. Let's put that in double quotes. That's going to be a string. And I'll create a new integer 42. Actually, I'm going to go ahead and test that just like that. Do a little, make sure I'm off to the right start before I dump a bunch of code in here. So this will be G++, and let me change my prompt here. Does anyone know why I always use bash for the name of my prompt? It's because I like to bash and smash things. All right. Yeah, it's just that's the name of the shell is all. All right. I just wanted to get in that stupid joke, so go to sleep at night feeling happy. And we got symbol.cpp and test symbol, test. GPO. All right, I'm not all the way there yet. So let me see. GPL type dot ch asterisk, dump that over there. Let's try that again. GPL assert. Try it again. Undefined symbols. Oh, that's because I've got additional CPP files here. So I have to add GPL assert.cpp and GPL type.cpp. Now I think I've got enough to, let me clear the screen and put that front and center up top here. That ought to do the trick. All right. No! Damn it. Line count. So where is that being declared? So I have to come back here. I'll grep for line count in all of the CPP files. Yeah, how about, it shouldn't be in a header file. Oh, you know, I bet it's. What am I doing now? So I can just hack this, but I want to get to the bottom of this. So what the? Oh, it's saying from GPL.L. I guess what I'll do is I'll go to my test program, oops, which I should have down here, and I'll just say int line count. Create that as a global variable there. All right. So that compiles, I can run it. It shouldn't do anything, which it doesn't. So now I can go back to my testing here. I know that that works. I haven't tested it for leaks yet, but we'll get to that. Maybe I'll create, let me just create, how about 3? We'll just create 3 of these. And I believe, so what I could do at this point is I could create a for loop to initialize each of those to 42. I think what I'll do is, I think I'm going to hazard a guess that this syntax works. And it does. So this is kind of a new standardized initialization mechanism here. Works in a lot of cases, including that one, which is convenient. Saves me some time on this test program. Now I'm going to create, oh, I guess I ought to give this, actually I ought to create a symbol. So we'll call this sim1. How about sim, let's create a coding system. Integers, case A. This will be integers, case B. No, I'm just going to call this a sim integer, and then this will be the sim integer array. This will be int array, and then this becomes int array, and there are 3 of them. Go ahead and do a courtesy compile. That's why we do the courtesy compile. Got an extra bit of goop there. Still won't do anything. Let's go ahead and print these out. Cout, semi, end line, cout, semi A, end line. So we can see something when we run it. Okay, so visually that looks correct. You will note when you, so the place where you would actually in your code be printing out the symbol would be in the symbol table, right? Your symbol table's got a bunch of smart pointers, shared pointers to symbols, and so you're going to iterate through that table just asking one symbol after another to print itself. The symbol table's got a really simple insertion operator. But to note, since they are pointers, that what your code's going to look like is something like that, where you're going to have an asterisk there to dereference it. So keep that in mind, that the actual code there in the symbol table will look different from what I'm hard coding here. All right, I guess I can go ahead and do a quick check for with Valgrind and confirm that there are no errors. And I get that possibly lost. I wonder what's possibly lost there. I guess I can go ahead and look that up. Let's do it like this. Let's clear the screen. Let's clear the history. Let's run it again. Conditional jump depends on uninitialized value. I don't think these are going to matter. Where is it? Yeah, these are all in some dynamic library. Get to the top here. I think I can ignore these. Those are the two. I don't know, maybe I'll look at it in a little bit and see if I can get to the bottom of that, but at a blush I wouldn't think that I would lose it. Where would the possibly lost be? I wonder if it's complaining about this. I guess I could take, what happens if maybe it's getting confused with that. Probably not. But, so I'll comment out that version, and then what I'll do is I will take this and I'll paste it right there, get rid of that. We'll just put that right in there, see what happens. Do the clear, run. Let me throw in debugging symbols. Yeah, it's still not happy. Gonna make it go all the way back. All right, I think I'm gonna let that one ride. I'll look at it in more detail offline and post what I think the issue is with that. Ideally, I don't want to see that. I'm certainly not seeing that with when I run my project through Valgrind, so I'm not quite sure what I introduced to, oops, I'm in the wrong class there. Not sure what I introduced to create that error. Let me see which ones, what was my old one? That one. And that one. Just for my own sanity. Let me just compile an empty main. Yeah, you see I'm still getting it with an empty main. Okay, so final test here. Let me comment out that. Oh, so that's very interesting. So something, well, I don't know what the hell I'm doing there that would be causing any trouble at all. Oh, it's the other. So it's got to be in this. There's something funky with this old code here, and I'm not quite sure why it's doing that. I'll investigate. Let me investigate that offline now that I've got it narrowed down. At any rate, we've got. So if I get to the bottom of that, I'll post something that makes that eliminatable. But you're definitely mostly concerned about definitely lost and indirectly lost. That's invariably going to be where your errors will come from. So coming back to our main program here, we tested with a single integer, we tested with an array of integers, and we went ahead and printed them out. And then I can basically just kind of rinse and repeat here. So 4yy, we'll paste those there. We change this to doubles. And what was it, 3.14159? And then this becomes, I have to change these. Come over here, compile. I of course had commented that out. I'll bring that back online. I'm just going to do a normal run. So that's what that looks like. I go ahead and do it with Valgrind. And I got that. And then you just go ahead and repeat it for the strings, right? So that's basically how you get that all tested. What else? Other questions? Yeah?
So for the, how do you do, like, check if it's an array or for the type?
So there are a couple strategies you can take. We've got, for the sake of the recording, for determining the type, if I look at what I've got for that header file, we do have this GPL type, right? So there are two ways you can do it. One is that for these individual, right, these are going to create constructors where that type variable on line 32 is going to have either int, double, or string, all in uppercase. And it's also going to set count to some invalid value, like -1 or 0 or something like that. I set it to -1. So one thing you can do is just check count. And if it's -1, you assume it's a singleton. If it's not, then you assume that it's an array. I think that's a real easy way of doing it. Another thing you can do is you can do stuff like if type and so here what we're taking advantage of is yeah, excuse me, that's true if it's not an array. There we go. Oh, I wanted GPL type.h. Right, so and I mentioned this before, we're taking advantage of the design of this was that a single bit is being used for each one of these, and if it's an array, it's its own bit, and so an int array is just the int bit and the array bit. So you can either strip it off, which I had accidentally been doing there before, or you can end it like this, and basically this is going to be either 1 or 0 if that array bit has been set on type. So you can also check it that way. I think I do something like that, except I go the other direction for whatever weird reason. Other questions? How about that singleton? Any questions on that? There may be some stuff that you haven't been exposed to before. I don't recall the extent to which I talked. Did I talk about the singleton at all before? Little. Let me find that. Did I talk about, what about these? Did I talk about, I guess the comments kind of explain it, but did I talk about that? This is actually, so I don't know if this explanation was clear enough, but as a C++ programmer, it's actually not a bad idea for most of your classes to throw these in there, because the compiler will generate these functions if you don't. And you may ask, well, what's the problem with that? If your class deals with dynamic memory at all, then these functions are likely going to get it wrong. So that's the reason why you don't want to trust the compiler to do it. And so this is an explicit way of saying, compiler, don't generate these functions. The more interesting question, and my 511 students would hopefully know this, is why did the language designers have the language generate these functions if they're problematic? Why are they creating headaches for us? What are they, first of all? What kind of function is 18? Yes, it's a copy constructor, which means that is whenever you're making an exact copy. So if I say sample singleton A, I can make an exact copy by saying that B is a copy of A. Right, that's going to run that function on line 18. And then, of course, the one on 19 would be something like B equals A. That's what that one is. Any guesses as to why the language designers provide those for us?
It makes strings work.
It's not to make strings work. It's actually the underlying reason for it is because of its historical roots in C, and it's really for backward compatibility with C. Because what classes have in common with C is the idea of a structure, right? Where a struct is just a grouping together of data, and for this, it is perfectly legal in the C language to assign one structure to another. So that got translated moving forward to C++. In order to allow that structure assignment, they had to overload that operator. And that's because structures are 99% exactly like classes in C++. What's the difference between a struct and a class in C++?
Defaults to private and one defaults to
Yeah, one defaults to private, one defaults to public. That's the only difference between the two. So for backwards compatibility with C, they do this. They also do this for backward compatibility. This one's a little more. This one's obvious. This one's a little more subtle. Where would a copy constructor be used, kind of C stylishly? Because you certainly didn't have this nomenclature in the C language where I'm explicitly calling it. It's where it gets implicitly called. Where does it?
in an array. Like for default values.
No, there wasn't anything fancy for default value. There simply were no default values in C for arrays. Has to do with functions. Say that again? Yeah, passing in parameters, specifically passing by value. So I have my void, my func takes a sample singleton myvar, and then when down here I call the function, I call my func and I pass in a. Myvar is an exact copy of a, and so myvar has to be constructed as a copy of a, so that's why the copy constructor has to be created, because you could pass in structures by value in the C language. If you're in C++ and you want to be efficient about it, you'd be passing it in by reference. And if you're in that's in C++, in the C language, you'd avoid the overhead by passing in a pointer, and then you'd make this the address of a. But that aside, from being good practice, it's certainly perfectly legal to do that in C, so it has to be legal in C++. What about static? What's the significance of the keyword static? Static. Static exists in the C language. So in the C language, let me see, I'll quit without writing out anything. Oh, where's my... So what kind of variable is this? A global variable. And that's true in C. Is that the same memory block? It is. So this has the exact same scope in whether or not I have static here. It has the same scope, which means it's global, right? It's going to exist for the length of the program. The static in this case means that it has internal binding, which means this variable wouldn't normally be visible in other quote compilation units, meaning other CPP files or other C files. So that's what that does. That's not hugely important. What's probably more significant is when I do this. So in its absence, that's just a variable that exists as long as this block is running. I've got a bad example here because this is main. What I need to do is do my func. So that goes from being a local variable that is created and dies with each invocation of the function to this, which is that is a variable with global scope, but its visibility is only visible within the function. Whereas outside of any function, the visibility is only within the file. So that's what's being taken advantage of with that sample singleton, is that this member function is basically creating one of these objects, and we want that object to be the only one that ever exists. And even though that, so it's static, it's global, its visibility is only within this function. However, you can of course return a reference to it, and then other people outside of the function can refer to it, right? So we get to ensure we only have one of them, and we can give it to others to use. The only kind of tricky thing is this one has to be created, and we aren't providing any information here, so it's a default constructor that has to be called. So we actually do have to declare a default constructor, and all we do is we ensure that that default constructor is declared in the private portion of the class so that outsiders can't create these objects. It won't compile if you try. It'll just say simply that this is private and you don't have access to it. Now, if you wanted to be smarmy, you could say, well, why don't you just go into this getIt function and create another sample singleton called, showed you, ha! And yeah, you can do that. You actually can do that, but why would you? You're writing the singleton class, right? You want its purpose for there to be only one. So don't be an idiot. You're just shooting yourself in the foot there. Right? If you only want one, just create one, make it static, and what we're enforcing is other users of the class are unable to create more than one. That's the whole purpose of it. Any other questions?
Step number 11.
Step 11. Absolutely. Write the action that accompanies the two variable declaration rules. Each action should allocate and initialize variables in an array, initialize both individual variables and each element of arrays using hard-coded values. Hard-coded values, it should probably say. So this is let me see, if I go okay, so what number 11 is talking about, and it's actually the bulk of the coding for GPL.Y, is that this is where you do something like double XYZ so you have to write an action that deals with that kind of variable, and you have to write an action that deals with this kind of declaration. In this declaration, an example of that is, what did I do, 3? So that's corresponding to that, the bracket, the expression, and in order to make things work, we changed expression to be t, what is it, constant int. So you had to make that edit to make our lives a little bit easier for this project. So this line is an example of when this rule gets called. This line is an example of when this rule gets called. So what do you, note an optional initializer. This would be, right, this is $1, this is $2, this is $3. We're totally ignoring this. So when it says hard code 42 if it's an integer, this float if it's a float, and hello world if it's a string, that literally means you're never looking at $3. You just ignore that. Don't do anything with it. Just hard code those numbers right here between these curly braces. So what do you have to do? Allocate and initialize variables. Well, you'd have something if simple type is int, new int, 42. Create a symbol, add it to the symbol table. We got that right here. So it's already a shared pointer at that point, so we probably want to do something like that here. Let me put that code for us to look at. So we can go to the test code we wrote. Let's grab this one. That's how we create a symbol. So I can get rid of that. And then that's how you create a shared pointer using that constructor. I don't want to call it my int. What do I want this to be? $2. $2 is a pointer, right? If I search for TID, it is of type union string. If I search for union string, that's a string pointer. So I don't want a string pointer. I want a string. So let me dereference that. How do you know it's an int? That comes from this right here. That means that you have to do something here, and I believe I cover that. Yes, so I actually just went ahead and threw that out to you. So let me just grab this little bit here. You will have done that. So when the compiler sees the word int, it's going to send this GPL type back down simple type, which comes here. So this is actually int. So we don't say simple type. We say if $1 equals int. We need to put that into our symbol table, which means we have to get our symbol table. Somehow we get our symbol table. Call insert on it, and then we just pass in our shared pointer like this. You can break it up into separate steps. I think this makes some people uncomfortable, so let me go ahead and just do separate steps for that. Shared pointer symbol is equal to, give it a name. FDSA is a nice one. And then I just shove this stuff. Get rid of some of these. And then this becomes that. You still have to get ST. This ST is your symbol table. Talk to table handler to get it. I think that's right. Is that right? No, is it just insert on the table handler and it passes it on down? All right. Table handler Table handler is your table handler. Talk to table handler. All right. I'll leave well. Now just leave it right there. TH is your table handler. So that's kind of how you'd go at it. It's fine to, can anyone give me, looking at the table handler, yeah, look at that, there's even a little code here. Let's just, since I provided some code, let's just throw it in there. Right here. So this would be tab hand. Is that complete? My comment's wrong now. Now I'm going to get rid of the comment now. All right. Coding's fun. So I've got 1, 2, 3 lines of code. Someone give me, the Ninja version. Someone help me do this in 1 line of code. Assuming you're inside the if statement. Oops. Feel the power. So that's kind of what you got to do. You have to figure out what type it is, make sure you're allocating the right kind of variable here, you're initializing it. You'll have to, I think you're not going to be able to avoid having some sort of loop to initialize the arrays. Now I avoided them in the test program because I hard-coded a 3 in there, right? But you don't know how large the array is going to be when this is running, so you're going to have to create some sort of iteration to initialize your array of doubles or integers or strings. Other questions?
You're gonna have to have a switch statement for the less than operator for a symbol to print out like int or.
Yes, I do have a switch statement in my insertion operator for symbol to decide.
Whether to print out int, double, or string.
Yeah. I think so. Sounds right. What else? All right, then what I'll do is I'll stop right here. Thursday's your last chance to make eye contact and ask me questions. Although I'm certainly available on Piazza, just don't wait to the last minute, so I'll be less available just before it's due. But yeah, try and crank away. Do some of this over the next 48 hours, so you have more questions for me. And then I may go ahead and throw out some new material tomorrow then if things are going slow. Okay? All right.